Okay, so let's take a look at what a product is. So a product goes back to when you multiply things together. So 2, let's say 2 times 3. Actually, let me do that a little smaller. A product is when we multiply some things together, and it can be more than 2 things. It can be 2 or more. So each individual thing is not called a product, but all of those things together is a product. All right, and maybe this product equals 30. So we can also say the product is 30. So we'll say the product is, right, equal sign 30. And that's the product of multiplying those 3 numbers together. So that's what a product is. I could say the product is these 3 things multiplied together, or I can just say the product is that side, whatever it's equal to, right? How does this relate to factors? Well, those things that we're multiplying together, I can stop calling them things. They're factors, right? We remember from last class that anything that when we are connected by multiplication, we call them factors. So this is the first factor. This is the second factor. And that is the third factor. But together, we would call that the product. And a lot of times we just refer to the result. The product, in this case, again, is 30. So I could also call that the product. All right, so that's how it relates to factors. So we just reviewed factors. Right? Factors means things that are multiplied or connected by multiplication. Whoops. Right? So factors are things that are connected by multiplication. That's a review of that. We also wanted to review degree. So if we have a polynomial in standard form, right, those are not connected by multiplication. It's connected by addition and subtraction. And the degree here is 2 because it's that highest power of x. If we have it in factored form, right, everything's connected by multiplication. So here again, this was connected by addition. Here we see it's connected by multiplication. And really, you need to think of this as repeated multiplication here. That will help you see the degree a little more easily. If you multiplied this out, this doesn't have an x in it, but when I multiply this x times this x, I'll get lots of terms, but the highest one it could possibly be is x squared. So now I would have a 4 times an x squared with some other stuff. And then when I multiply this x squared times this x, it'll get lots of terms in it, but the biggest one it could be is x to the third, right, with the other stuff in it, but who cares? The biggest one is x to the third. So this would be a degree 3. Okay, we don't have to multiply it out. We just think if we did, basically like this would produce 2 x's. This would produce 1 x because there's only a 1 out here. And so when we multiplied everything together, the highest power of x would end up being 3, so we would call it degree 3. We have names for these degrees, so that's the other thing we wanted to review from last class. So if I had like a little chart, I'm not going to name them all again. Let's do it this way. I'll just give you a couple. A degree 2 was a quadratic. I know that's weird because 2 in quad. Quad sounds like 4. Degree 3 is a cubic. A degree 4, this is degree, and this is the name. A degree 4 would be a quartic, like a quarter. There's 4 quarters in a dollar. All right, so that's our little review. And now we know what product means and how it relates to factors. So now we're going to look at this thing called the zero product property. If a product is 0, then either factor or both must be 0. So that means if I write that out sort of in mathy like terms, it means like if I have 2 things times each other and it equals 0. So that's the if part. A product is 0. Remember, this is the product. and we say is for equals 0. So if a product is 0, so if we have this going on, remember that these are called the factors because they're connected by multiplication. Then either factor must be 0. So if we have this situation, if the product is 0, then A must be 0 or B must be 0. Or it could be both. We've sort of always known this since like grammar school, right? The idea would be like if I asked you what is 2 times -4 times 7.8 times 0 times 15. You don't need a calculator or anything really to think about this because you already know the zero product property. This is kind of in reverse. Since one of the factors, right, I've got 1, 2, 3, 4, 5 factors, only one of them needs to be 0 to make the whole thing equal to 0. So that's kind of the reverse of the zero product property. We've already sort of known this. Multiplying by 0 is very powerful. It makes the whole product 0. If any one factor is 0, the whole product becomes 0. Okay, so let's use that an example to solve this equation. Solve for x. I notice that I've got things connected here by multiplication, so it's in factored form. We've got 4 factors. This is the first factor, this is the second factor, this is the third factor, this is the fourth factor. That's how I look at it, right? If any one of those is 0, the whole thing equals 0. Well, these aren't 0 and they can't be changed. Those are already fixed as numbers. They're constant. They're fixed. This one could be any number I like. I can make it 1, I can make it 7, but none of those make the product 0. By the zero product property, the only thing x could be is x would have to equal 0. That would make the whole thing 0. So to solve for x, the solution is x would be 0, and that would make this statement true. So solving when something's in factored form, solving when it's equal to 0 is so easy. You basically just have to find out what makes that factor 0, right? There could be 2 solutions. That's what I'm showing here in example 2. I've got 4 factors. This factor is always 5. It's not going to produce a solution. It could never be 0. This factor is -7. It's never going to be 0. It's always going to be -7. But this guy here could be 0. So one solution will be x equals 0. But now there's a second solution because there's a second factor here that could be changed. Or y could be equal to 0. So this has 2 solutions. Okay, and that's kind of weird at first to see there's 2 solutions. But if either thing happens, the whole thing's 0. Now the key here is if x is 0, if I plug in a 0 for x here, it doesn't matter what y is. They don't depend on each other. That's a very important point as well. If this factor is 0, y could be anything. So when x is 0, y could be 2, y could be 7, y could be 8. It doesn't matter because the x being 0 zeroes out the whole thing. And the same thing is true of y. If I make the y 0, then x could be anything. X could be 1, x could be -2, x could be pi. It doesn't matter what x is. If y is 0, the whole product is 0, so that's a solution because we want to find the x and the y that make this entire product equal to 0. So let's look at how we solve polynomials in factored form. So solve for x. We've got something like this. I see multiplication here, here, and here. So this is in factored form. We've got 4 factors. And they equal 0. Both of those things have to be true. So I have to start, I say like, okay, I have a product here. And my product is equal to 0. It's kind of written backwards, but the product is 0. So since the product is equal to 0, that's very key. It has to be equal to 0. That's the first part of the zero product property. If the product is 0, then this thing can work. So since the product is 0, I've got my 4 factors. What x would make this first one 0? Well, I just say x equals 0. That's a solution. How about this one? If this factor was 0, so I can just write it out. This factor is x plus 5, and I need it to be 0. Now that's not solved already, but if I could make that equal to 0, I could find an x that can make that 0. Some of you could just think of it. Well, if I plug in -5 for x. that would be a solution because it would make that product 0. You could do it more technically without having like thinking through it, is by saying if I want to solve this little equation now, it's like a little mini equation. I could subtract 5 off both sides and I arrive at x equals -5. So far I've got 2 solutions. Now there's 4 factors and each factor has an x in it, so that means there should be 4 solutions. So for this guy I've got x minus 7 equals 0. If that factor equals 0, then the whole product would equal 0, right? So that's another solution. It's this, or it's this, or it's this. So if I add 7 to both sides, I get 0 for that factor. The last factor, again, I set that equal to 0. So if I force this factor to be 0, that would also be a solution. So if I add 2 to both sides, I get x equals 2. So in this case, I actually have 4 possible solutions. I do want to take a moment to talk about checking your answer. You can't plug these in all at the same time. Some students think you can do that. Let me just look at the answer like x equals -7. If I want to check just that answer, I can plug it back in for x, but I have to plug it in everywhere for x and see if it makes a true statement. So if I plug 7 in for x here, I get 7. If I plug it in here, I get 7 plus 5, which is 12. If I plug it in here, I get 7 minus 7, which is 0. That's the key one. And if I plug 7 in here, I get 7 minus 2 is 5. Now I multiply these products, I multiply these factors together to get their product and make sure and verify it equals 0. So 7 times 12 times 0 times 5 is 0 because that's the powerful multiplying by 0. Zeros out everything. Check, it works. So 7 makes the third factor 0. If I plug 2 in everywhere, I'd get, let me erase this, it's getting a little busy. If I plug 2 in everywhere for x, I'd get a number here, I'd get a number here, I'd get a number here, but the key is I'd get, so I'll just say this is some number, this is some number, this would be some number, but here I would get 0 when I plug in 2. So 0 times all those numbers, it doesn't even matter what they are, that equals 0. I want to look at this last 2 examples here. This one's the same as the one above it. The only difference is we will never write, if we have just x, we won't write it in parentheses. I just want you to get used to seeing that. It's still 4 distinct factors. We do it exactly the same as above. And then let's look at this last one. I see 4 factors here. Some people say there's only 3 factors. Why would they say that? Because this factor doesn't have an x in it, so it won't produce a 0. This first factor, I'm going to say there's 4 factors here for now. This first factor of 4 can never be 0. So it doesn't produce a solution here. This one's only going to have 3 possible solutions. This could produce 0. So I say, what x would I choose to make that whole thing equal to 0? I can see that it's -5, or I can just set up this little mini equation and solve for x. That's a solution. -5 would make this factor go to 0. And then I wouldn't even care what the other factors come out to be because multiplying by 0 would 0 out everything else. So that's one solution. If the next factor is equal to 0, I could solve that little mini equation and get a solution. And then this guy as well, I can set up this factor and solve and get another mini solution. So this would have 3 solutions because there's 3 factors that contain x.